Hey guys, this is going to be a quick tutorial on how to calculate eigenvalues using a sum n by n matrix. For this, it's going to be a quick 5-minute video on how to calculate a 2 by 2 matrix. So using the Calvis 2018 book that we use in our MATH3195 class, this is from the Calvis 2018 Pearson book. The definition they have for eigenvalue is that the number lambda is said to be an eigenvalue of an n by n matrix A, provided there exists a non-zero vector such that A of some vector is equal to the lambda of some other vector, in which case the vector V is called an eigenvector of a matrix A. We also say that the eigenvector is associated with the eigenvalue, and vice versa. So that's a lot of jumbo, but essentially you're going to be given some n by n matrix, and that's going to be equal to A. So if you multiply your original matrix by some vector, that you're going to find that that's going to be equal to some single lambda value. It could be complex, it could be just any real number, but that multiplied by the vector itself again, it's going to be a representative of the same solution. And we'll prove that towards the end of this example. So how do we solve for eigenvalues? In particular, you can go to page 340 to 342 for more examples in our textbook. But the most common method is using the characteristic equations. And the goal of just using characteristics equation is to be able to compute the determinant of A minus lambda of I, which is the identity matrix. So for a 2 by 2 matrix, the identity matrix is going to be equal to 1s across the diagonal, okay? So in such case, what we're going to get is we're going to get lambda times that. So we get lambda 0, 0 lambda. And then now we're going to do this function, this matrix, 5, 7, -2, -4. That's equal to A. We're going to subtract the two. What we're going to end up with is this. We have 5 minus lambda across the diagonals. We got 7, that remains constant, -2, that remains constant, -4 minus lambda, okay? So far what we've done is we've just looked at what our matrix A is, and then found out what the identity matrix is, multiplied it by lambda, and then this is what we end up with, okay? Nothing too complicated. Now, we're going to set this equal to 0 as what they want us to do in the definition. We're going to set this equal to 0. And part of finding that the determinant of a 2 by 2 matrix, or n by n matrix, in this case it's 2 by 2, as you can see, we are going to end up with this equation where we basically multiply these two and we subtract the multiple of these two, okay? Now I'm going to do that over here, so give me a moment. We have 5 minus lambda, -4 minus lambda, minus these two multiplied, so we have -2 times 7. So what you'll end up noticing is that you end up with a quadratic equation. Now I've worked this out earlier, but basically you want to solve this out. We have lambda squared is equal to lambda squared minus lambda minus 6, okay? Now, this, as you know, in polynomial functions, you can actually have complex roots, you can have real roots, and you can have you can basically have a mix of those two as well. But those are the two main roots that you will find, and the roots themselves are going to be considered the eigenvalues. So if you plug this to a calculator, in this case we don't really need to, because looking at this problem you can determine that it's lambda plus 2, lambda minus 3 is equal to 0 after simplifying that. So then the lambda values must be -2 and